Hi all, welcome back. This is Series 11 video part 6. Here I am going to discuss with the introduction to event-driven architecture and AWS MSK Kafka. So this part is only theory portion where I will cover only some theory concept. In 10 to 15 minutes, I will try to close this. Let's start for that, right? So agenda for discussion for today, we'll discuss what is event-driven architecture, event-driven microservices architecture. We will check it out, how it is showing in that. And then Apache Kafka problem with previous architecture. So what is the use of Kafka for solving that issue? Now I will give the brief introduction about the why data streaming is required. So that after that, I will cover that Apache Kafka introduction. Then Apache Kafka architecture, we will discuss on that. And then Apache Kafka API and advantage for that. And then what is the use cases and examples for? And what is the key features and key benefit for MSK serverless? I have covered this topic here for serverless here. So let's start. First one, what is event-driven architecture? That event-driven architecture is a software design pattern in which it is decoupled the application and can asynchronously, this is the main thing, publish and subscriber to events via an event broker or message broker. So what we are doing, we are using the event broker or message broker between the subscriber or consumer that we can, I will show you in the diagram those things also. And in an event-driven architecture, application communicate with each other by sending or receiving event or messages. So this is the sending or receiving event or messages between those. And event-driven architecture is often a asynchronous communication because it is sending messages to the Kafka and Kafka storing those messages until it is delivered. Event-driven apps can be created in any programming languages. Because event-driven is a programming approach, it is not a language, right? This is the main thing here. Event-driven architecture is a loosely coupled architecture. Let me take the pen. Yeah. This is loosely coupled. Now you can see this diagram. This is an event-driven microservices architecture. This is the message broker here. And it is taking, suppose in any website, it is ordering service is fired. Then what is happening? It is running one microservices one where our order service is running. Then in order service, create an event for the order. Then message broker will send that request to the multiple microservices or multiple services for that, right? Like it will send order to the stock service. It will check for the payment service, send request for the packaging, email, SMS, all are the microservices, different microservices. So it is triggering automatically from message broker to those microservices for that. So what is the problem for the previous architecture? We are, suppose if we are using the 4 source system and we have a 6 target system, then integration is required between the source and target. That is 24 integration is required for that. So that is the challenges, right? And each integration come with different difficulties around, suppose protocol. What are the protocol we are following in each integration? What are the data format for that? It is binary, CSV, or JSON. What is the schema for that? How data is saved? So that is the issues we are getting from that previous architecture, and each source system will have increased load from the connections. So how to solve those things, that problem? This is the problem for the Apache Kafka. This is a solution we can solve for decoupling or data streaming in system. So what we are doing here, we will use the Apache Kafka for here, and source system or producer, we can say any name for that. Source system producer, there's a different type of sources we can use for that, and all sources will communicate with the Kafka. And in the target system, we can say the target system are consumes. Who will consume these messages from Kafka? That may be database, any analytics, any audit, any email system that we can take from there. So it is totally decoupled all those things between source and target, right? So before moving ahead, just want to discussing about that why data streaming is required. What is data streaming, right? So data is the heart of the every business today. Every business is producing tons of data. This data could be generated through customer interaction, through business processes, and through financials, anywhere. And other sources maybe we have for that. So businesses have realized that they can generate a ton of value from these assets. It's actually an assets, right? But to create the value of this asset, we need to use it well. And this data has been produced in high volume and from a variety of data source today. So it is highly varied and it is being produced at high volume. It is coming at high velocity. So we able to create value and need tools for storing them. After analyze the data to draw insights, which will give actionable insight that we can implement and improve business outcomes or customer experience, which we can improve it. Some of the popular tools are already used by the customers, which are data warehouse, data lake. This is already given by that services. So data warehouse is which we can dump data in the form of the data tables, and we can run queries against them. Typically, these are used to run reports, and we can look business historical data and create and see daily reports. So this is daily report generation. We can use those things. And the data lake, which we can collect the data from multiple places and use it to feed off machine learning model. So we can create a model and feed that model, and we can take the prediction on that. Or otherwise, whatever we have other tools, we can use it. Now, data streaming value of data diminishes over time. But we know that the value of data diminishes over the time diminishes very quickly. In the diagram, you can see here, we have 4 bars. One for the real time, second one second, minutes, hour, and day, months. The leftmost is the real time bar, which is basically telling that the value of data in the maximum if it is used right away. See, it is a maximum value it is showing. Now, obviously, we'll all have no such thing in real time. But the closest we can get to real time, right? So we can draw maximum value out of it. We can take preventive actions, such as maybe something is about to go wrong, or maybe our alarm are firing off. And if we can take action based on that, so that we can prevent our system outage. That is advantage we can take from there, right? We can predictive actions. Taking the example like, for example, suppose software has visited website and do certain actions such as views or click on some website. which can generate insights in the recommendations. And we can show this recommendation on that page also. That is the advantage, for example. And let me take the another example for this. Suppose a gamer who is playing a game and he's taking certain actions. But on that, we can show an in-game purchase offer. And the same time, we can offer those things. Now, if we do not react on those things in real time with real-time data, then we will lost this opportunity where we can get benefit from it, because duration of this window is very less. In the graph, we go further towards the right. On the order of minutes and hour and day, it become more much reactive and historical. So I'm telling about this, right? So at the last, it is only for the history purpose we can store the data here, right? Now, data stream is the ability of process the data in the real time. So as the record come in, we are able to process them one at the time and draw insight out of them. It will give a new real-time insight and allow to basically capture all of the value in the leftmost bar, so that data stream become very important. These are the tools that can ingest a large amount of data at extremely high throughputs and make them available for consuming application at very low latencies. So data stream become important. AWS offers multiple solutions in this space. We have a Kinesis data stream, which allow to ingest petabyte scale of data and make it available to analyze. Variety of other AWS services such as AWS Lambda, Amazon Kinesis data analysis, and many more. So Kafka, this is introduction. Apache Kafka is a very important popular tool. It is an open source event streaming platform, which is basically is an open source project under Apache Kafka Foundation. It is a much like Kinesis. It offers low latency and extremely high throughput, and it can fan out of thousands of customers without really affecting the performance of the system. So we can fan it out to so many customers. Other important is Kafka is streaming data stored in decoupling application. This is discussed in last slide earlier. And low latency, high throughput, high performance, fault tolerance, and scalable. This is there. Apache Kafka is used to support a real-time application that transform, deliver, and react to streaming data. This is the architecture for that Kafka. So details, you can see the producer is here and consumer groups are there, broker, this is a Kafka cluster, this is a broker, topics, and partitions. Topic contains broker contains multiple topics, and topic contains multiple partitions, right? And you can see the zookeeper. Zookeeper is store the metadata information, in which Kafka store the details of the consumer and cluster configuration. All those details is happening storing here. And topic, if I discuss topic define the category in which the producer pumps the messages and pump the messages here in the topics. And depending upon the type of message, there is a new topics created. So we can create a multiple topics in particular in each broker. So broker is nothing but the nodes. So we can use the multiple nodes, so that is called the broker. In broker, we can create a multiple topics. In under the topics, we can create the multiple partitions. Partitions is just contains ordering message from producer, writing on each partition is sequence process that increase the Kafka performance. And this is producer is used to produce the system messages and push into the topic. And this consumer is used to subscribe the particular message category topics. This consumer read messages from the topic. So basically, it is sending message topic in this partition, and consumer is taking those messages from particular topic, then go to the same partition, right? This is calling like that. Broker, topic, and partition. This is sequence for that. Now we are using the Apache Kafka API, multiple API we are using for those things: producer API, consumer API, stream API, connector API, and admin API. The major 5 API we are using for that. So what is the advantage for that Kafka? This is highly secure, highly available, because advantage of multi-agent replication. Privately connectivity, fully compatible. This is Apache Kafka application on AWS without changing our source code, right? Distributed, or we will cover this thing, show you in the demo section also. And this is distribution is resilience architecture, fault tolerant, horizon is scalability is there, can scale up to 100 Docker over there, and 100 Docker you can create a multiple topics, multiple partitions, so in the architecture diagram, right? Can scale to the millions of messages per second. This is high performance, latency less than 10 milliseconds. It is real time, I can say near real time, near about real time, right? And observability is good. Monitor logs and metrics via CloudWatch or some other monitoring tool like Prometheus we can use for those things. Rolling version updates are there. The multiple advantage we can get it here. And now what is the use cases for that? And use cases is first for the messaging system, activity tracking, and gather metrics from many different locations, applications, log gathering, stream processing using Kafka Stream API, decoupling of system dependencies, integration with Spark, Storm, and Hadoop, like multiple things, right? Now, what is the examples for that? Mainly, we can see examples of the Netflix, Uber, LinkedIn is the major we are using over there. And Airbnb, this is used mainly for the Europe and other countries for that. India, I think we are not getting those things, but it is using that Kafka and Walmart. Now I will cover here what is the MSK serverless key feature, because two type of MSK provided by the AWS. This is a provisions and one is a serverless. So serverless mainly contain those features. This is on-demand streaming capacity, throughput-based pricing, auto partition placement, fully compatible, same security as MSK. MSK means this is for the provisions one. This is by default provision, and second one is serverless. Same high availability as MSK, not MLK. MSK, right? So this is same as MSK. This is a part. This is a provision one. This is basically. So mainly on demand is very important here, because if you are running your system in a certain period of time, then it is a go for the the serverless. And in serverless, we don't need to do anything. It is a automatic partition is happening, automatic throughout based pricing. Something is there. So it is a very, if you don't know about more about that, then you can go for the serverless. So key benefit is there, simple to use, lower operational overhead, cost effective, right? And mainly, what is the difference with that MSK provision and MSK serverless, right? Or you can say simple MSK over there, right? Is the control over there, stable and predictable workload, larger workload, we are going to use this one, right? But MSK is serverless we can use for getting started. A specific type of workload, offload capacity management, because we are using something only for, suppose if any your server you are using for only 9 to 5, then you go for this serverless. So we can reduce our cost using this thing, right? Same thing what you are doing in Lambda function, right? And nothing we need to do. So, but if you have a large workload, then go for the MSK provisions, right? That is the important. So now in the next video, part 7, we will go some demo on that. And first I will cover that provisioned MSK cluster, and I will show you how to produce the messages and how to consume those messages using the MSK cluster. So we'll create this cluster first. We will create producers. The producer I will use for EC2 instance for that, and consumer I will go and use the EC2 instance. So I will use the two consumer for that. So this is C1 and C2. I will use for that. Both are EC2 instance, and producer also will run on EC2 instance. And in between, I will add this cluster over here, and it will send the message, produce the message, and consumer will consume the message from here, right? That I will show you in this next one. So it is a very theory part. This part I have put because I just want to give you a basic idea about that, how MSK is working, what is the streaming, this little bit idea. So we will get understand this practical labs, all those things. So after that, 7, 8, and 9, all three are the labs for MSK. So please check those things. So I've done in this part 6, and we will meet in the next part. If you like this video, please like and subscribe my channel. Thanks for watching it.